Hello and welcome back to Maths Made Easy. Today we are going to solve question number 21 to 30 from exercise 7.2 chapter 7 class 12 integral. Detailed solution with example with explanation. These are some basic results in integration. If you need, please take screenshot of this. We may use this. Question number 21, 10 square 2x plus 3. Okay, we don't need to substitute anything here since it is very simple. I will show you how. Integral of 10 square 2x plus 3 dx. We are going to integrate this trigonometric function and then divide with the derivative of the other function, whatever may be the function. In this case, this is algebraic function. So, but before that, we have to make sure that tan square, we have the integration of tan square. Since we do not have, we will be converting it into sec using the formula of identity. So, tan square x can be written as sec square x minus 1. Now we will be integrating it. Integration of sec square x dx minus integration of dx. Since there is minus 1, so I will write here nothing instead of minus 1. Now, integration of sec x, it is tan x. So I am going to write here tan x whole divided by derivative of x. That is the function. In this case, our function is 2x plus 3. Integration of 1 is x. Since there is minus, so it's minus x. Derivative of 2x plus 3 is 2. Finally, we got our integration, that is tan 2x plus 3 upon 2 minus x plus c. Let's move to the next one. Sec square 7 minus 4x. Same as before. This is already sec square. We know the integration of sec square is 10x. So let's apply. 10x whole divided by derivative of x, that is the function. Any function it could be. We have to get the derivative of that function. This is algebraic function, so I will write d upon dx of 7 minus 4x. Finally it is minus 4. That's it. Sine inverse x divided by root of 1 minus x square. Let us take sine inverse x as t. Why? Since the derivative of sine inverse x is available here, d upon dx of sine inverse x dx, dt upon dx, derivative of sine inverse x is 1 upon root of 1 minus x square. This dx will come here in the numerator. So we have dx upon root of 1 minus x square as dt. So in this part is going to be our dt, and this is t as we have assumed or substituted there. So I is equal to integral of sine inverse x upon root of 1 minus x square dx can be written as t times of dt. Now you all know what is integration of x, that is x to the power 1 plus 1 upon 1 plus 1, 2. Same. T square upon 2 plus c. Don't forget to resubstitute the value of t, that is sine inverse x. I is equal to sine inverse x to the power 2 upon 2 plus c. Easy. Let's move to the next one. Question number 24. 2 cos x minus 3 sin x whole divided by 6 cos x plus 4 sin x. What I can do here is I can take 2 common from this part. So I will be having 3 cos of x plus 2 sine of x. And now the derivative of this part is available in the question. Derivative of cos x is minus sine x and derivative of sine x is cos x. Derivative of cos x is minus sine x and derivative of 2 sine x is 2 cos x. You will see how. I took 2 common. 3 cos x plus 2 sin x is equal to t. d upon dx of 3 cos x plus 2 sin x is equal to dt upon dx minus 3 sin x plus 2 cos x dx is equal to dt. Now you can compare it with our question that we have 2 cos x, okay, there. Do we have minus 3 sin x? Yes, we have. So this whole part is t, I mean dt. And this part is t as per our substitution. So we have 1 upon 2 integral of dt upon t. We all know that 1 upon x is log x. When we want to find the integral of 1 upon x, it's log x. So similarly, 1 upon t is equal to log of t with respect to t. Don't forget to resubstitute the value of t. One upon 2 log of 3 cos x plus 2 sin x plus c. 25. 1 upon cos square x 1 minus tan square x. Okay, what we can do here is 1 upon cos square x can be written as sec square x. Sec will go up, and we all know that derivative of tan x is sec square x. So this is going to help us. I'm going to take 1 minus tan x as t. 1 minus tan x is equal to t. Derivative of 1 minus tan x is equal to dt upon dx. Derivative of 1 is 0 and minus is as it is, tan is sec square x. So I have sec square x dx is equal to minus dt. In our question, sec square x dx can be written as minus dt, and this part I have substituted as t. So we have minus of dt minus integral of dt upon d square. Later this can be written as t to the power minus 2 and then t to the power minus 2 plus 1 divided by minus 2 plus 1. We get I is equal to 1 upon t plus c. And after resubstituting the value of t, that is 1 minus tan x, we have our final result. Integral is equal to 1 upon 1 minus tan x plus c. Let's move to the next one. Number 6. Cos of root x upon root x. Okay, this is very simple. Let's take this root x as t. d upon dx of root x is equal to dt upon dx. Now derivative of root x is 1 upon 2 root x is equal to dt upon dx. So finally we got the value of dx upon root x as 2 dt. This 2 I will shift to the other hand. So in our question, dx upon root x, I can write 2 dt and cos of root t, cos of t. See, we come to till here and cos t, same this statement. Now integration of cos t is sin t, and don't forget to resubstitute the value of t, that is root of x. So final integral is equal to I is equal to 2 sine of root x plus c. Question number 27. Root of sine 2x dot cos 2x. Okay, I will take sine 2x as t. Derivative of sine 2x is 2 cos 2x. So I can eliminate this part. Let's see. Sine 2x is equal to 2. Derivative of sine 2x is equal to dt upon dx. Further, derivative of sine 2x is cos 2x dot derivative of 2x. What I did here, I did the derivative of trigonometric function and then algebraic function. So we get 2 times of cos 2x, cos 2x. I will send this 2 to the other hand. Cos 2x can be written as dt upon 2. Okay. Root of t can be written as t to the power 1 by 2. And then apply integral 1 by 2 plus 1 is 3 by 2 whole divided by 1 by 2 plus 1, that is 3 by 2. This 2 and 2 get cancelled. we have 1 upon 3 times of t to the power 3 by 2 plus c. Let's resubstitute the value of t. Integral is 1 upon 3 sine 2x to the power 3 by 2 plus c. 28. Cos x upon root of 1 plus sine x. Very simple. I'm going to take 1 plus sine x as t. So, derivative of 1 is 0. Let's do it. Let 1 plus sine x is equal to t. Okay. D upon dx of 1 plus sine x is equal to dt upon dx. This is 0 plus cos of x dx is equal to dt. Cos x dx can be replaced with dt. So we have dt upon root of t. We have dt upon root of t. Integration of 1 upon root 2 is 2 root. Integration of 1 upon root t is 2 root t. If you remember the yesterday's lecture, I just derived this value. Now resubstituting the value of t, that was 1 plus sine x. So final integral is equal to 2 times of under root 1 plus sine x plus c. Cot x dot log of sine x. Let's take log of sine x as t, because log x derivative of log x is 1 upon x, and since it is logarithmic function and trigonometric function, first we will find the derivative of logarithmic function times derivative of trigonometric function. Let's see how. D upon dx of log sine x is equal to dt upon dx. Derivative of logarithmic function is 1 upon x, so 1 upon sine x times derivative of this other function, that is trigonometric function. Derivative of sine x is cos x, so cos x upon sine x dx is equal to dt. That means cot x dx can be written as dt. That means this cot x and dx over here is going to form dt, and this log of sine x is already t as per our substitution. So we have integral of t dt, and integral of t is equal to t square upon 2. So t square upon 2 plus c. I will be resubstituting the value of t, that is log of sine x. So final result is log sine x to the power 2 upon 2 plus c. Let's move to the next one. Sine x upon 1 plus cos x. Okay. Let's substitute 1 plus cos x as t. Since the derivative of 1 is 0 and cos x is minus sine x. Just we will play with the minus sign to get sine x dx as t. 1 plus cos x is equal to dt upon dx. 0 minus sine x dx is equal to dt. So I will be taking this sign minus to the other hand side. So sine x dx is equal to minus dt. Meaning here we can write dt. So minus of 1 upon t dt. Again 1 upon x, integration of 1 upon x is log x. So this becomes log of t, and resubstituting the value of t, that is 1 plus cos x. So our final result is I is equal to minus log of 1 plus cos x plus c. So that is it for today. I hope you liked this video. If you did, then please subscribe to my YouTube channel. I will see you in the next one. Thank you very much.